Polynomial functions. Let n be a non-negative integer. A polynomial function is a function that can be written in the form f of x equals a sub n x to the n plus dot 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 a sub 2 x squared plus a sub 1 x plus a naught. This is called the general form of a polynomial function. Each a sub I is the coefficient and can be any real number, but a sub n cannot equal 0. Each expression a sub I, x sub I, or xi, x to the I, is a term of a polynomial function. All right, so that's just the general form of a polynomial. There's one more thing that should be addressed here. N is also a finite number, so it can't be infinity or anything like that. It has to be some non-negative integer, so some finite number. All right, now below is some terminology we're going to talk about of polynomial functions. So we talked about the idea of a coefficient. So the number that's going to be times each x variable are called coefficients. But this one here is called the leading coefficient because the highest exponent for the variable is in this term here, which tells me then that coefficient on that x is the leading coefficient. And we also have this thing called degree here. Degree is just that power of the variable. We're going to talk about that a little more in a second. So it's just the degree, it's just the exponent number there of the highest highest exponent term on the variable. Okay, and here it's also called the leading term. So the one that's the largest degree, which means it has the largest exponent on the variable, that term is called the leading term, and the number that's multiplied times that x is the leading coefficient. And one more thing here. When I talk about the idea of terms, terms are separated by pluses, minuses, and equal signs. So if I look at this here, dot, 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 a squared, a1, a naught, this is going to be n plus 1 terms. Because think about this. Here's 1, here's 2. And if I go all the way to n, that's n of them. But I also have a sub naught, so that's n plus 1. So this one actually has n plus 1 terms because, remember, terms are separated by pluses, minuses, and equal signs. So now what we're going to do is we're going to get more involved with these and do some problems. So here we go. Here's a list of problems here. We're not going to do all these. We're just going to do a few of them, though. It says, for the following exercises, find the degree and the leading coefficient for the given polynomial. So what we're going to do is we're just going to take a look at the number 12 here. So it says find the degree. So I look at the exponent on the variable, and it's 4. And I only have one term here. Having one term is called a monomial. Mono meaning 1. And I know we didn't have to say that here, but I did want to express that to you. And it says find the degree and the leading coefficient for the given polynomial. So the degree of this polynomial would be 4. Degree is 4. And the leading coefficient is -3. And make sure you put the negative in it because it's -3. It's the number for the term that has the highest exponent on the variable. All right, let's take a look at 13 now. 13 is what we would call a binomial because it has 2 terms. Term bi meaning 2. And with this one here, we're going to look at each term in this and determine the degree of that term. And the highest degree term is the degree of that polynomial. So what I mean by that is when I see a constant here, the degree of a constant is 0. So I'm just going to write deg 0 for that one. It's not Dago, it's deg 0. Okay, so anyways, now the next one here, which is this term, that degree is 2. And it's 2 because the exponent on the variable is 2. So that's called degree 2. So what that means for us here is when I look at both of those together, the degree 2 term is bigger So therefore, the whole polynomial is degree 2. Now it wants the leading coefficient. So the leading coefficient is -2. So there's that one there. Let's try one more of these. We can go all the way to number 15. And that one's kind of interesting there because it's not multiplied out. So we're going to actually have to multiply that one out to understand what those are. So here we're going to have to do a FOIL and then times it by x possibly. It doesn't matter which way we go. It's going to be the same amount of work. So I'm going to leave the x outside for now and just multiply the inside. So that's going to be 8x when I multiply those together. And then when I multiply the 4 and the 1 together, I'm going to get a 4. And then the -x squared and the 2x cubed, that's going to be -2x cubed. Or x, yeah, 2x cubed. And then for the last one, it's going to be -x squared and 1, so it's -x squared. And I'm just going to rearrange it and descending powers. I always do that with these, but before I do that, I'm going to distribute my x through now. So yeah, I might as well do that first. Okay, so anyways, 8x squared plus 4x minus 2x to the 4th minus x cubed. And then I'm just going to rearrange these. Now, I don't have to do this problem. I don't have to arrange it. I just like to because it makes things real clear for me as far as where everything goes and what it is. So now the leading coefficient for this one would be this term here, because when I look at the other ones, that's a degree 3, that's a degree 2, and that's a degree 1. Since I don't see anything there, it's understood to be a 1 as an exponent. And this is 4, so degree 4 is the largest. So I would say for this one, it's degree 4, because that's the largest one, degree term. Okay, and then the next thing, the leading coefficient then, and that's going to be -2. So there's our answer for this one here. So it just kind of gives us some insight on how we classify them, and you'll see problems like that in a book, and you'll be able to distinguish what they're talking about and what it means. All right, so there we go. We're just going to do those 3 problems.